In this video, we're going to practice graphing the cosecant function. But the first thing I want to do is fix what's going on the inside of the function. Anytime I have a b value, like this 3 here, and a potential phase shift, which is not pi over 6, I need to factor out the 3. So I'm going to go ahead and do that right now. So if I take that 3 out, put it outside of parentheses, then I'm going to have x plus. Now, to know what goes next, I need to take pi over 6 and divide by 3. I've learned that dividing a fraction by 3, I can just put that number in the denominator. So this is going to be pi over 18. So that's going to be my phase shift. Does that make sense so far? Yeah. Okay, so that's the key. I'm going to put all of this in parentheses. Hold on, these little random marks are bugging me. And then I've still got the plus 3 out here. This is cosecant. Okay, we're going to need to know what's going on with the period. So the period is always the regular period, which is 2 pi for cosecant. 2 pi divided by the b value, which is 3. So the period is just 2 pi over 3. We will deal with the x-intercepts and the asymptotes later. But the phase shift, I see the pi over 18. I'm just going to change the sign. Will be the opposite. So this is going to be negative pi over 18. And you should go ahead and say left. All right, that is going to be the phase shift. Every minute that you're doing this problem, keep in the back of your mind that cosecant is the reciprocal of this sine function. For that reason, the first thing we're going to do is create a sketch of the sine function and then use that as the basis of our graph. Whenever you have a phase shift, I recommend starting at the phase shift. Normally, if I graph a sine function, I would start at 0. But not this time. Oh no, I'm going to start at this phase shift instead. I'm keeping in mind that I'm going to have a vertical shift of positive 3, so I'm going to try to leave myself room for that as well. Okay, so I think right about here should be good. So I have this phase shift of negative pi over 18. So for that reason, over here on the left, I'm going to put negative pi over 18. That's going to be my first value. Now I'm going to mark off 4 places as I move to the right. So 1, 2, 3, 4. That'll be one full period of this function. Now every space that I just marked is 1/4 of the period. So this is where I do that thing where I say, well, wait a minute, what is 1/4 of the period? What is a quarter period? Well, in this case, the period was 2 pi over 3. So a quarter period should be 1/4 of 2 pi over 3. Well, wouldn't that just be 2 pi over 12? And that simplifies down to pi over 6. So pi over 6 is a quarter period. That means every one of these marks should be pi over 6 more than the previous mark. So if I start from my phase shift, I should be able to get all the other marks by adding pi over 6, adding pi over 6, adding pi over 6. So that's what I'm about to do. So I need to do negative pi over 18 plus pi over 6. Okay, so what do we have to do anytime we're adding fractions? You need like denominators, okay? So obviously 18, let's go with that since I already got the 18 there. So that's why I'm going to take this and I'm going to multiply it by 3. All right, so hopefully you can see then that pi over 6 is the same thing as 3 pi over 18. So I just said I was going to add pi over 6 over and over again, and I'm going to do that, but I'm going to do it by adding 3 pi over 18 over and over again. So let's do that now. It's going to be really easy. Okay, so I'm starting at negative pi over 18, like sort of like negative 1 pi over 18. If I add 3 to that, that's going to be 2 pi over 18. If I add 3 more, that's going to be 5 pi over 18. If I add 3 more, that's going to be 8 pi over 18. And if I add 3 more, that's going to be 11 pi over 18. Is this making sense so far?
Yeah, I got it now.
Okay. I put these down low so I would have room to reduce. So that's what I'm going to do now. 2 pi over 18 is just pi over 9. 5 pi over 18 does not reduce, so I'm going to keep that. Let's see, 8 pi over 18. 4 goes into this. No, okay. 4 pi over 9, I guess that's the best I can do. So 4 pi over 9. And 11 pi over 18 doesn't reduce. Okay, great. I'm going to need the y-axis on here now. The y-axis always goes at 0. But I don't see 0 anywhere on my y-axis. I mean, anywhere on the on my x-axis. I don't see 0. So where am I going to put the y-axis then?
Between negative pi over 18 and 9 pi.
Yeah, I'm just going to put it between the negative and the positive. So the y-axis is going to go here. All right, I see the plus 3, and the a value is 1, so I'm going to have to go up 1 even more than 3. So I'm going to have to go up to a height of 4. So I'm just keeping that in mind as I count. So I'm going to go 1, 2, 3, 4. The midline is at 3. So I'm going to go ahead and put my midline down. The amplitude of the sine function that I'm about to sketch is 1. So what I like to do is I put these yellow lines. They're very faint, and I know they're hard to see, but that's on purpose because I don't want them to clutter up the graph too much. But they help me to see the amplitude of my sine function. All right, they just make my graph a little more accurate. Okay, so now it's time for me to sketch the sine function, which again I'm sketching because cosecant is 1 over the sine function. It's the reciprocal of the sine function. Remember that the phase shift was negative pi over 18, so that's where my first dot goes, on the midline at negative pi over 18. So there's the first dot. Next, at pi over 9, I'm at the high point. At 5 pi over 18, I'm back in the midline. At 4 pi over 9, I'm low. And at 11 pi over 18, I'm back at the midline. So I'm just going to make a very light sketch of the sine function. Okay. Now, everywhere the sine function touches the midline, that's where the asymptotes are going to be, vertical asymptotes. So I should have a vertical asymptote here where the sine function touches the midline. So there will be a vertical asymptote right here. There will be a vertical asymptote right in the middle at 5 pi over 18. And there's a vertical asymptote at the end. Okay? I have learned that the cosecant function has the points in common with the sine function at the high and the low. So this high point and this low point are on the sine function and the cosecant function. So I can use this high point and just approach the asymptotes, going away from the midline. And I can use this low point and again approach the asymptotes, going away from the midline. All right, so the blue graph is a graph. That's our final picture for this cosecant function. That's what your picture should look like. Now here it says x-intercepts. I do have x-intercepts. I can see down there that it's going to touch. But without a graphing calculator, we really can't find those intercepts. So I shouldn't have put that on the question, so I'm just going to take that out of there. Now, I will talk about the vertical asymptote equations. I like to start with my first positive vertical asymptote, which is at 5 pi over 18. And I'm going to say x equals 5 pi over 18. And then I need to add how much I would need to get to the next vertical asymptote. And I notice that the next asymptote occurs half of a period away. See how it's only 2 spaces? It's not 4 spaces. It's only half of a period. So I'm going to add half of a period. A full period is 2 pi over 3. So half of a period is pi over 3. So if I were to add pi over 3, that would get me to the next asymptote. But I don't want just the next asymptote. I want all of the asymptotes forever. So if I put a multiplier on this, if I call it n pi over 3, then if n is 1, that gives me the next asymptote. If n is 2, it gives me the asymptote after that. I'm going to call n any integer. That way, if n is negative, it will get me the asymptotes that are going to the left. All right, I'm going to add one thing on here that we haven't talked about yet in class, so I encourage you all to listen that are actually physically sitting here. Another thing that I could ask you that I didn't, what about the domain and range? We should talk about that. It would be valid for me to ask you what's the domain and range for a problem like this. We've talked about the domain, so I think you all probably already know that, but the range is where it's new, so everyone should listen. Let's do the domain first. That's pretty easy. The domain, basically we're saying the domain is all real numbers except for the vertical asymptotes. So you have to say it this way though. So the domain is all real numbers, so you kind of make this fancy R for all real numbers. And then to say except for the asymptotes, we'll just say x cannot equal, and then we'll just copy our vertical asymptote equation. X cannot equal 5 pi over 18 plus n pi over 3. Okay, that's how you would write the domain. Now, let's talk about how you would write the range. The range is the y values that we have here. All right, I think I'll put the range all the way over here. Let's talk about the range. For the y values, we're going to have to do the range in 2 different portions. We have this lower section of the graph, and then we have this upper section of the graph. So we'll just have to do the range separately for each part. So let's start with the lower section, because you should always do the range from bottom to top. So what is the range, one of you people that are alive right here in this room, what is the range of just the bottom portion of the graph? Can you tell me that? Owen, jump in there.
Negative infinity to 2.
Negative infinity to 2. That's the range for the bottom portion. So I would write that just like this, negative infinity. Owen, for that 2, should I put a parenthesis or a bracket?
Bracket.
A bracket, because it touches the 2. So negative infinity to 2. Now I have this upper portion that's not connected. Does anybody know from another class, there's something you're supposed to put in between the two portions when you have two separate parts? The little U for union. So I'm going to say union, and then somebody else other than Owen, can you tell me the range of the upper portion, Adriana? Bracket 4 to infinity. All right, picking up from the bottom and going up. All right, is that what you were going to say, Rihanna? All right, so I just wanted to mention that because you are responsible. I could ask you guys for the domain and range for problems like this as well. All right, that's going to do it for this video. I hope it was helpful. I will see you on the next video.